What the hell? I know those are not tattoos. They're moving.
All rise. The court is now in session. The Honorable Paul R. Doyle Sr. presiding. Please be seated and come to order.
To the viewing public, I realize that you may have little or no interest in this presenter's message. I am using the presentation in service of providing expert feedback on delivery, content, and production value as a learning exercise. To the presenter, I will remain silent during your presentation. I will, however, make running commentary on the screen. I will render an oral judgment at the end. You may appeal my judgment to the viewing public. The viewing public is your jury. The viewing public has the final say. Proceed with your presentation.
Why do I study war? War is interesting, war is iconic, and war is full of hidden history. War is iconic. It's full of heroes and villains on both sides, and its symbols are instantly recognizable, such as the powerful image of a flag raising on Iwo Jima in 1945. War is interesting. It shows the extremes of human behaviors on both sides, and its use of strategies, weaponry, and equipment is constantly evolving. And war is full of hidden history. War was the reason the military first funded science and technology and was the first to integrate. And war is geologically creating a mark on the stratum of the earth that's defining the Anthropocene. Today, I'm going to talk about that geological mark, specifically the one from Battle of Iwo Jima in 1945. The U.S. Pacific Fleet landed on Invasion Beach in 1945 for the reason to overtake Matiyama airfields for access and control to secure the Pacific, because the ones who held the airfields held the Pacific. Today, Iwo Jima, or Iwoto, is more than a geological battlefield. It's an environmental time capsule, one that's closed to the public and only used by the military, which is how I was lucky enough to visit when I served in the United States Navy. While I was there, I got to visit the stunning landscapes of Iwo Jima. I got to see and admire the beautiful monuments and encounter extraordinary relics. In addition, I got to venture the vast tunnel system constructed by the Japanese in defense of the inevitable battle. In addition, I walked over the famous black sands of Invasion Beach, and it was here I got to collect my black sands. But I wasn't the only one who was collecting black sands. Other US service members also were collecting sands as a form of war mementos. It would be later that I'd learn that the Japanese refer to the soil as Azura Seki, or consecrated soil. And they believe that the blood of the soldiers is sanctified in the soils, and therefore they do not follow the American custom of collecting the soil. In these sands, a hidden history is found. These sands are the fog of war. They hold everything in a historical reference. They capture everything that falls indiscriminately, with some of the most insidious being heavy metals. Heavy metals like lead and mercury. Heavy metals are toxic, but not only are they toxic, they do three things really well. They bind to soil particles, they resist natural degradation, and they persist for generations. So, how much heavy metal is left on Invasion Beach? To start, we're going to have to go back in history to Iwo Jima prior to World War II, or prior to the Battle of Invasion Beach, with mapped out enemy installations in 1944. from aerial imagery taken during the aerial bombardment. It includes condensed enemy installations across Invasion Beach, which is important because it's where heavy metals and munitions are more likely to be in heavier concentrations. When the battle commenced, Marine divisions landed in color-coded battle sectors, with green zone being at the base of Mount Suribachi and being for tactical landings and supply, while red and yellow zone was for the 5th Marine Divisions, which landed in order to take over the airfields and Mount Suribachi. And then most importantly, blue landing zone 1 and 2, which was used by the 4th Marine Division, which was the heaviest zone of battle, meaning that the focus of the battle was here, and also where I was lucky enough to collect my soil samples. Another important thing about the Battle of Iwo Jima is the aerial bombardment that took place 5 months prior to the battle. 500 and 1,000-pound bombs were commonly dropped on the island where Mount Suribachi, the airfields, tunnels, and beaches were. Each bomb deposited lead and mercury and other heavy metals along with its physical destruction. Strategically, it was also common to bomb around the airfields and not directly on the runways, so that post-battle, they would still be operational. These bombs left impact craters measuring from 6 meters to 12 meters. One night, I counted all of the impact zones in an aerial image, and alone I mapped out 852 impact zones. So this made me question how much of the battle was aerial munitions. Well, it turns out that 50% of the battle was aerial munitions alone. So I wanted to find out how this actually compares to heavy metals in the soil. So how much heavy metals in the soil, such as lead? Well, for lead, that's about 273 tons of lead deposited on the island of Iwo Jima across 5 months and 36 days of consistent, sustained battle. That's the equivalent of 2 Hiroshima bombs, 26,000 car batteries littered, or 225 million gallons of gasoline burned. So, how much of that lead actually hit Invasion Beach? Well, from my research on the military's archival data, about 30% or 90 tons of that 273 tons was actually deposited on the beach of Invasion Beach. And I wanted to figure out how much lead that was per scoop of soil. So we're going to do some math. I know that's not everybody's favorite subject. Don't worry, I already did most of it for you. Okay, so I created a lead contamination prediction model to estimate long-term pollution, specifically from World War II munitions on Iwo Jima. So the formula integrates multiple environmental factors, including decay rate, precipitation, dispersal dynamics, oscillation, and soil retention, all into this predictive contamination model. And after 80 years of environmental impacts and decay, nearly 19 tons, or 21% of that 90 tons, is predicted to be on Invasion Beach today. So I had to do a little bit more math to figure out how much it was in the scoop of soil. And so I took the remaining lead and put in milligrams and divided it by the soil mass of Invasion Beach, or the top 10 centimeters, and calculated 155 milligrams of lead per kilogram of soil across Invasion Beach. So I wanted to compare this to what actual samples would be. So I took the soil that I had and what others had given me as well, and I split this into test groups, and I tested them on the XRF, or X-ray fluorescence machine, for heavy metal concentrations. And some of the samples I was actually able to publish in an earlier publication, and others I actually saved to show you guys today. The predicted lead contamination model of 155 milligrams per kilograms of soil closely aligns with my unpublished samples, a sample average of 147 milligrams per kilogram of soil. This differs by less than 10 milligrams per kilogram of soil. And it moderately exceeds my published sample averages of 121 milligrams per kilograms of soil. So this is a significant step forward, because if the model holds for lead, it could potentially be used for other heavy metals. As a next step, I wanted to test out mercury using my lead prediction model, and to test out the predictive potential beyond lead, and assess its potential use across other war-impacted environments. So don't worry, I won't make you look at any more math. But here's the exciting part. I just wanted to let you know that it worked not only for lead, but for mercury. And it held up both across published and unpublished results. This means that the equation isn't just a one-time trick, it's actually a framework, a way to predict contamination across multiple metals with real-world validation. So now that we've seen that it works and that we can estimate what's beneath the soil, and not just from history books, but from an actual scientific prediction, what do we do with all of it? Well, we can see how this data compares to lead safety thresholds, but first we have to look at what is considered safe and by who, such as the World Health Organization, whose lead limits concentration is at 100 milligrams per kilogram. Here in California, we recognize 80 milligrams per kilogram, and this is important because this is when lead begins to decay human cells. So the WHO greatly differs from our US standards, and the US often disagrees with their own standards. The EPA limits are at 400 milligrams per kilogram in residential zones. That includes agricultural soils and playgrounds. So this is far above when lead actually begins to harm us. These standards are often not based on health, but on economic feasibility, political compromise, and industrial lobbying. In many cases, the acceptable limits are actually what is convenient for governments and industries to manage. And what of the environment? The bombards stripped away natural vegetation and left behind a toxic legacy of heavy metals that inhibit plant growth and soil health. Marine life near the coast struggles with bioaccumulation of these heavy metals, and vegetation in and around impact zones struggles to regrow as well. Volcanic soils, while rich in minerals, are actually highly retentive of heavy metals like lead and mercury. So the result is an ecological status, an island where life has struggled to fully return almost 80 years after the battle, a place frozen not in time, but in toxicity. This isn't just Iwo Jima. From Ukraine to Vietnam and Gaza and Iran, battlefields become long-term pollution sites. Communities are left to live with these residues. Imagine trying to grow food in contaminated soils, or trying to raise your family and pets using water that's been tainted by war. This is environmental injustice, plain and simple. What's even more harrowing is the time scale. Pollution in the 20th century is affecting ecosystems and human health in the 21st, and will continue to do so in the 22nd. Globally, militaries are among the largest polluters. Yet when we talk about climate change, sustainability, or environmental justice, the environmental cost of warfare rarely enters the conversation. So what is our military leaving behind? Our military is leaving behind neurological disorders, reproductive disorders, neurological delays, developmental delays in children. This is happening right now in communities near or around conflict zones. This means that these communities are often exposed to levels of lead and mercury that wouldn't be considered safe and would not be tolerated if there were stronger accountability measures in place. Policymakers must recognize that war is not just a geopolitical crisis, but an environmental one. They must recognize that even cleanup can be costly and could potentially compromise culturally significant lands. We should focus on educating veterans and civilians about contamination risks and hold our militaries accountable. This isn't about erasing or changing history. This is about healing the land that holds it. I think about the residues collected in our mementos, in our war memento soils. It's not just environmental residues, they're historical, cultural, and psychological. Residues that build up over time. The black sands of Iwo Jima hold way more than just memory. They hold the weight of the war's hidden toxic legacy. If we want a truly sustainable future, we must reckon with the past. We must acknowledge the invisible wounds of our soils, waters, and communities, because nothing truly disappears. Thank you.
Carrie, your TED Talk was eye-opening and jaw-dropping. Thank you for educating us. You and I chatted briefly during lunch break in the hallway. You may remember that I shared with you that my great-uncle was a chaplain standing within 5 yards of that flag raising at Iwo Jima. So, Carrie, here's what worked. Some of the images and the last 4 minutes of your script. What needs work? The delivery of the last 4 minutes of your script. You are a research scientist. Research scientists present their results at research conferences, a formal event. TEDx was not a research conference. You had some flexibility in the delivery of your message. I'm okay with your reliance on the teleprompter for most of your presentation. You can actually use that to your advantage. At 12 and a half minutes, start to move around and across the stage. The audience will be like, why is she moving now? This must be important. Make eye contact with the audience, pick out some friendly faces, connect with your audience, and then dig down deep as you deliver your message. Show your emotion. I felt it when you sighed. More of that. Not all the time, though. Pick and choose your battles. Let your guard down, not so much self-control. Be vulnerable. I know it's not easy to show your emotions in front of strangers. I know that from personal experience. I started acting 2 years ago, Carrie. I had a leading role in a short film screened at an Oscar-qualifying film festival in July 2024. And the role required an emotional breakdown. One take in front of 30 strangers. So here's a tip my acting instructor gave me in preparation for my emotional scene that you can use. A touchstone. By that I mean a physical object that is a source of inspiration. You are emotionally connected to the physical object and you tap into that emotion. In your case, your touchstone is the black sand from Iwo Jima, the war memorial soil. I picture you holding it up, showing it to the audience, as you say your line, "This is environmental justice, plain and simple," delivered with the fervor of a Baptist preacher. When you talk about the neurological disorders, stir up the audience emotions. Leave your audience with a feeling that matches your final words. Nothing truly disappears. Carry on, Carrie.